Okay, the time's come for us to connect to the device in question. Now, I've already demonstrated that we were connected via SSH, so NXOS 1, 2, 3, 4, 5. And I showed you, as a direct result of the ACI diag command, that I could take a look at the Fabric node vector read output, and we can see that we've discovered this switch, and we know that that's leaf 1. We've already gone through that verification. Now, a lot of people are asked, well, what if I just do ACI diag and I hit enter? Well, it's going to give me a list of different commands that I can enter. But what I want to call your attention to is, if you should ever forget or get lost, you can always use the ACI diag -h syntax, and it's going to give you the output in human readable. So if we look here, we have the fabric node vector. So we've got read fabric node vector. We've got the fabric node vector read in extended mode. So these are all things that you guys can play with at the command line. Just keep in mind that the -h basically gives you more information than just being able to hit the configuration. And also, I mean, if you want to be able to use things like configurations, so let's say I was going to look at the verbose, but the V would be show show fabric node vector read -v, and I haven't really used the V too much, so -h -v for verbose -v fnv read. I'm just curious to see if I can get it to give me out. There it is. So basically the V here, where is it, is giving me additional information, but like I said, I'm not liking the output values here. So tells me where it's actually finding the keyhole. So this is basically where the ACI access is going through. So we can see here it's basically curling that information out of the table, and it's providing the information. So as an example, I could use this to query for the purposes of being able to use things like curl. So that's not going to be too helpful for us at this particular juncture. So the point is what do I need to do and where do I need to connect to? Well, if I come over here and say show interface brief, notice I see output as if this were a switch, but it's not a switch. And what we see here is I'm not seeing any values. So what if I do a show IP interface brief? Will that work? Well, I see IP interface brief, but I'm not seeing any IP addresses. What I'm getting at is this is not a switch. This is a server. We're actually SSH'd into the console of the server of this application. And it's a Linux server. So what if I do something like ifconfig pipe more and look at the output here? Well, we see here we've got all kinds of interfaces. We have Ethernet 1, 2.1, Ethernet 2.2. We've got a loopback address with the 127.0.0.1 address on it. Where I'm going to is right here. Remember I told you that we would issue an IP address out of the out-of-band management VLAN into the system? Well, this is the IP address that we want to connect to, the same one that we're SSH to. So what I'm going to do is I'm going to go in here and I'm going to see if I can actually connect to it. So I'll say 10.1.255.252. Actually, I'll go ahead and just do HTTPS to be safe. Shouldn't be a problem. Self-signed certificate is going to require me to hit the advanced option and to accept it. Again, I'm a Mac user. And we should find ourselves presented with a login screen to be able to access this APIC. Now, we've been having some really crummy weather here, and my bandwidth is not that great, so I'm hoping your mileage may be better than mine as far as speed. But basically, I'm going to log in with the admin, capital NX, lowercase os, 1, 2, 3, 4, 5, and hit enter. And what we should be presented with is the very first screen for our APIC, which is going to basically say, hey, you're running version 3.1, and it has these new features. And what's new? So right now I'm going to go ahead and say close, but you can see here in this version we have lots of new capabilities. We have the AVE, we have ACI multi-site enhancements, we have remote leaf functionality, we have MACsec configuration, we have the ability to be able to integrate layer 4 through 7 services into cloud orchestration through the use of containers. We have the ability to be able to implement tetration. All of these different elements all made possible by this particular version of the ACI operating system. and the version that we have. And right now what we're doing is we are presented with our primary user interface. Now you'll see it's going to be flashing here. You'll see a red message here. This is basically saying, hey, you've only got one APIC, and that is not going to be supported in production. We also see that we have options that we can look at with regard to system, tenants, fabric, virtual networking, layer through layer 7 services, administration, operations, and apps. We're not going to concern ourselves with a whole lot of these right now. I want to spend the majority of our time here in the fabric. But before I do that, I want to call your attention to the fact that there are no health scores on this page at all. And if we were to take a look at these values, I'll go ahead and minimize this drawing console here. I have a system health, I have a node health, and I have tenants. Well, it should stand to reason that I don't have any values here for health about nodes because I have no nodes. That's where we're at right now. We want to be able to discover nodes and integrate those nodes into our fabric, which is why I'm going to click the Fabric tab. Now from the Fabric tab, I'm going to have 3 Fabric tab options: inventory, policy profile, fabric profiles, and access profiles. Now, the way this works is inventory is going to be associated to devices that I can manage and devices that I'm connected to that I can't manage. The fabric policies is going to apply to policies that I want to apply between leaves and spines. Access policies are going to govern policies that are going to dictate how devices that are going to be connected to leaves are going to behave. So it should come as no surprise right now. It only makes sense that I spend time in inventory, because what I'm going to do is I'm going to be adding nodes. Inventory is going to define what nodes are part of the fabric. Fabric policies govern the way those nodes are going to behave and operate with one another. And then the access policies are going to determine how endpoints are going to connect to the system. So when I talk about switches, you'll hear me use the word nodes. When I talk about hosts, virtual machines, bare metal servers, or switches, I will be calling those endpoints. Because ultimately what we're going to do is we're going to take endpoints that we're going to give identical treatment, and we're going to place them into endpoint groups, or what we call an EPG. But that's putting the cart before the horse. Right now what we want to focus on is building this fabric, and that should be no surprise if I come over here and realize we have this fabric membership tab that we need to work with. But before we do that, I'm going to click the Topology tab. I like pictures. The Topology tab is going to show me the infrastructure associated to my fabric. In other words, it's going to give me a listing of all of the devices that my APIC is connected to. Now we know, based on the fact that we've already executed the node vector read output on a particular switch, that the only thing that we see is one switch, but it's not showing up here. And it's not showing up here because it's not been registered to be under the control of this APIC. It's just been discovered. So that LLDP message has gone out. So in order for me to take that switch and make it part of the management plane of this APIC, what I need to do is I need to assign it that node number and the node name. To do that, I'm going to go to Fabric Membership, and I'm going to be confronted with a table. Notice it says here I have that serial number. Remember, 0 Tango 2 1. It is pod ID 1. I need to give it a node ID. To do that, all I'm going to do is just double click here, and I'm going to type in 101. Now I can identify a remote leaf TEP pool. I'm not going to worry about that, so we don't need to focus on it. I don't have any devices that I can pretend are remote leaves. I'm going to go ahead and give it the last piece of information I said that we'd have to dictate, which is going to be the leaf name, or the node name. Now notice it detected it as the correct model, and in this scenario what we're going to do is it is a leaf based on the fact that it sees the ALE. I'm going to go ahead and hit update, and we're going to apply that information. Now we're going to wait here, and what we're going to do is ultimately we're going to see, notice it says, is it a supported model? Yes. Is the SSL certificate accurate? Not applicable at this time. And notice I have no IP address. This IP address is going to be the TEP. This is going to be the VTEP address, that /32-bit address that's going to get assigned by the system. Now I'm basically waiting for this thing to appear, and while I'm waiting, I'm going to go ahead and grab my SSH session to my APIC. And what I want to do is I want to see if I can see things changing. So what I'm going to do now is I'm going to say show switch. And what we should see here is it does indeed see a switch. We gave it a name of 101, and now we can see here that we've refreshed and we actually have a TEP address. Now, what I'm going to do is I want, can I scale this thing down so I can get a little bit better output here? And what I'm going to do is I'm going to repeat this command, and we're going to see exactly what I wanted to see here. Notice I have an address. That address is that TEP. It's right here, and it is a /32-bit address that's been assigned. Can't tell that here. We'll see that in a little bit. Notice there's no in-band IPv4 address. There's no in-band IPv6 address. There's no in-band IPv4 address. I'm sorry, out of band, and there's no out of band IPv6 assigned. It is running this version of the code. If we look at the criteria here, it tells me it's active. It tells me it is a leaf. It tells me that it is in service, and it tells me that the certificate, i.e. the SSL certificate, is valid. All in one output. I see the serial number and the leaf identifier. And notice here I now see my spine. I see it's a spine because it's identified as a spine. But that won't show up here because this only shows me the output of devices that have been added to the fabric. If I want to see that other leaf, I need to do that output of fabric node vector read, and now you'll see here I see the other device. Notice it has no information associated to it. Everything's good to go. Now, what I want to do before I connect to the spine and configure it, I want to connect to that leaf. So how can I do this? Well, I know that I could go in and I could connect to it from my CRT session, but I can also jump to it from my APIC. All I have to do is say SSL2 leaf-1, the name that I gave it, and it'll ask me to log in NXOS 12345. And what we're going to do is we're going to see things have changed. Notice it now knows who it is. It is leaf 1. Now if I say show IP interface brief on this device, and we look at the output of this, here's what I want to illustrate. Notice loopback 0, that address of 10.0.72.65, 10. Where is it here? That's the 7.0. That's the IP address. Let me see if I can drag this over. All right, so 10.0.72.64. That's the number I'm looking for. 10.0.72.64. Same address. Notice it was assigned to loopback 0. It is a /32, even though it was issued out of that range. But that range just defined the mask that we used of /16 just said I have this many interfaces. And notice that there's that logical interface that I have set up. And notice it is actually using IP unnumbered, and it is tied to loopback 0. Now when we start looking at this, what we're going to find is these are going to be the interfaces that are going to be connected to other devices. Now, with this being implemented, I want to go through and do the discovery for everything. So what I'm going to do is I'm going to call this spine 201, and what we'll do is we'll just call it spine-1, and I'll hit update. It'll get an IP address. The secure socket or the SSL should actually come up as valid once we have verified the certificate authority, and ultimately we should discover leaf 2. And then what I want to do is I want to take the opportunity next to explore the topology drawing. So let's get everything discovered first, and then what we'll do is we'll look at how the topology drawing has been modified. In fact, while this is actually doing its thing, let's go up here and take a look at the topo. And we see I have the APIC is now controlling leaf 1. Now it's not saying it sees leaf 1, it's saying, hey, this leaf is now registered as being managed by this APIC. And then what we will ultimately find here is this thing should actually add spine 1. So I'm just basically waiting. So here, let's go ahead and get out of here. So I'm going to say exit. And we shall say show FNV read. There we go. We see the other leaf. We see state active. So it should actually appear here now. Sometimes the GUI is just a little bit behind the CLI. So again, just waiting. I know it's there. It should be there because of the show switch command. You'll actually see it now in the entry. Actually, it's still compiling. If you ever run into a situation like this where you basically enter a command and it goes and doesn't do anything, you can execute a Control-C and it'll actually return And what that is it's basically compiling the information that you're trying to look at, and it's taking the system a little bit of time to do it. So there's that spine. So like I said, it takes a little time for all of this to actually propagate and get implemented, but I'm missing my other leaf. So how do I get that? Well, let's go back to my Fabric membership, and what I'm going to do here is I'm going to see the node ID. I'm going to do 102, and we will call this leaf-2, and I'll go ahead and hit update, and then ultimately this will be added to our configuration. Now keep in mind, everything that's added to this APIC I can now manage from this APIC as if they were a single distributed switch. And that's the beauty of this. The beauty of the ACI is not just in its ability to be managed via policy, it's also dictated by its ability to be able to manage every device that is part of the fabric as if I had one big, huge distributed switch. It is virtual in some ways and physical in others. So it's kind of like a distributed para-virtualized switch. Because remember, at the end of the day, we're slapping ASICs behind things in order to be able to get advanced functionality. So in here, notice I'm having some issue. The status right now is currently unknown. IFM is trying to communicate. And if I go down here and look at unreachable nodes, excellent. Nothing's appeared, so it should actually come in. I was just kind of concerned about that. And we're waiting for this thing to finally transition. So let's take a look at the output of the show command here for show switch and see if it does see it. Yep, it's there. It's going to go in. I'm just waiting for it to set up. Notice the only difference here between this device and the others, the spine, is it's an ASIV, and S stands for spine. So let's see if it actually does its thing. Yep, it's, again, Control C. So I'm just basically being impatient. It's hard not to be impatient, but it always pays. So let's see if we can see an output now. Nope, not yet. Now I don't have to Control C. It will ultimately throw the output up there, but what I'm going to do is I'm going to come over here and see if I can't hit refresh. There we go. It's gone active. Let's take a look at the output here. We'll go ahead and Control C again because I am impatient. And there's my output. So if I come over and take a look at the topology drawing, let's see if it's added all devices. So my APIC and my spines, or my spine, my two leaves. Now, I want to call your attention to the fact that this is not just a management as far as being able to send policy interface. I can actually look at things associated to these switches. So if I go to pod, which is going to give me a listing of the devices that are part of this configuration. If I go ahead and hit the down arrow, you're going to see leaf 1, leaf 2, and spine 1. If I go to pod and I go to interface, what this is going to do is it's going to let me look at the front console of these switches. Now I only want to look at the leaves. So what I'm going to do is I'm going to add leaf 1 and I'm going to add leaf 2 to the configuration. So I'm going to do shift leaf 1 and click on 102. And what we're going to see here is now I'm looking at my front panel interfaces. Ports 48 go to my APICs. We can see here for the usage it says controller, EPG, infrastructure. 48 down here does the same thing, so they're both connected to that APIC. Port 49 is the interface that I use to connect to the spine, and we see that it's defined as a fabric port. The fabric port is very, very important to me. Now, when we look at this in our labs, these interfaces, different people are going to be using different interfaces as we do implementations, because the first thing that we're going to explore is the idea of connecting these leaves that are part of the ACI Fabric to leaves that are not part of the ACI Fabric. And in other words, we're going to be connecting to what are referred to as unmanaged fabric nodes. And you can see here, I've got a lot of unmanaged fabric nodes that I am connected to. So we're going to play around with different aspects and different components of this, but ultimately the goal here is that by looking at this configuration, I can look at the operational state of these interfaces. Well, what if I want to look at the configuration state? Well, welcome to ACI version 3.1. By clicking here, I can see how any of these individual interfaces are configured. So if I wanted to change this interface right here and this interface right here to a fabric extender, click, assign it a FEX ID 101. Well, it's going to be 101 to 199. Go ahead and hit submit, and kapow, it's actually going to configure those ports. Purple tells me that they are going to be configured as fabric extender ports. But there's something that I want to show you, and that is from the command line here. So from the APIC, if I do show run, what we're going to see is I see the output for the APIC, But what if I wanted to look specifically at, say, for instance, an interface on this switch that I just configured? This is leaf 1. Well, I got a couple of options that I could do. First of all, what I could do is I could say show run leaf 101. And what will end up happening here is it should give me the running configuration. Now notice the only thing that shows up is what I changed. Everything that is white is unmodified. Looking at the output here, I can see interface 5 and interface 6 are configured as Fabric extenders, and I speak Nexus. So I'm looking here and say, oh, FEX Associate 101, FEX Associate 101. So those are the configurations. But here's something that a lot of people don't understand. Unlike the Fabric extender in the UCS, where the Nexus operating system is read-only, the ACI doesn't do that to us. The ACI gives me configurational control from both the graphical user tool and from the command line. So that begs the question, how do I connect to this leaf? Well, I connect to this leaf by first of all going into configure. And notice here I'm on the APIC. Now what do I want to configure? Well, I've got 3 things that I can configure. I can configure the APIC, I can configure leaf 1, I can configure leaf 2, and I can configure spine 1. So the question is how do I tell it what I want to do? Well, all I'm going to do is I'm going to say connect to leaf 101. So it's almost like attaching to a line card in a 7K. So now from here, if I just execute show run, this is going to look really familiar. It's only going to give me what has been changed. But what if I want to modify it? Well, I'm in config. You know, we have keys to the kingdom. Let's go in here and say interface. Now, shortcuts can bite you in the butt, so definitely pay attention to what you're doing. But I'm going to connect to Ethernet interface 1.5. All right, so yeah, Ethernet 1.5. Oh, I'm in the interface. So it's not like iOS. It's a little bit different. So you have to be in the right context to be able to enter things. This was not taking because I was in interface 1.1. I could execute where just like I can in a Nexus device to see where I'm at in the configuration. So it tells me I'm on leaf 101 and I'm attached to interface Ethernet 1.5. Now all I want to do is I'm going to say no FEX Associate 101 and hit enter. Now if I do a show run, take a look at the output, what we're going to find is that the only interface here that I have is going to be for this interface. Now this bothers people because it's different. If I execute show run, it's showing me I'm doing the show run of the configuration that I'm in. Let's exit out and let's say show run. Notice 6 is still configured. But the output that I entered before was from within 5. So let's go ahead and I'm going to say interface Ethernet 1.6 show run. Notice it's giving me the running configuration of the interface that I'm in. So there's no need to do things like section and include and stuff if you are currently in the configuration spot that you're wanting to operate in. So under the interface, it only gives me the running configuration for that interface. So it's only the running configuration for the context. Here it's going to give me the running configuration for the context, which is the leaf, which is going to be show run. Now, ideally, notice it didn't change anything here. Well, it didn't change anything here because all I need to do is refresh. And when I refresh, what we're going to find is that value now changes. I could put it back. I could come in here and say interface Ethernet 1.5. And what I could do is say FEX Associate 101. Hit enter. And if I come over here and I do my refresh, what we're going to find is that it should put it back. All right, now notice I have effects. There's a Fabric extender. That sucker's been discovered. It's running because I have pod 1 currently up and operational. The first 6 interfaces are pod 1. The next interfaces are pod 2. In our labs, obviously, we're going to have to break things up because we have far more than 12 students or 6 students. So what we'll end up doing is we're going to be breaking things up at first into interfaces. But now all of a sudden, this Fabric extender is now part of this switch. In fact, if I go to the 5K, and I say, excuse me, interface, Ethernet. Let's give it a try. Let's see if I can address that interface. So let's see, again, I'm in the context of interface. There we go. Now if I say interface, Ethernet, and we look at the options here, notice I have option 101. I can go 101, 1, 1. So what I'm doing is I'm actually going to this interface right here. So if I come over here and go to this interface and I do a show run, what I'm going to find is there's no config. But if I wanted to change that interface, I could do that. Now, one of the benefits that we also have in the system is if I go back to the APIC, and what I'm going to do is I'm going to change the state of these interfaces right here. So how do I change the operational state of an interface? Well, one of the things that I could do, actually I need to refresh this screen. And let's see. It's not going to let me do it. Effects configuration. So what I'm going to do here is I'm going to say unconfigure. And I'll come down here, say unconfigure. Yes. Submit. I didn't submit on that first one, so I'm basically going to be taking the Fabric extender out of the equation. Now, I'm not a big fan of attaching Fabric extenders to leaves, but Cisco definitely makes it something that you're going to be incentivized to know. So let's see if it repeats. It's got to disconnect that FEX. Now, another thing that I could do is, what if I wanted from the command line to access both of these switches? Well, remember I did config. What happens if I type leaf 101 and leaf 102 and hit enter? Well, let's see. Let's take a look at the syntax here. So, leaf 101 to 102. If I do where, what we're going to find is I'm actually in both of these. So if I connect to an interface, Ethernet E15, it's not going to like that. But if I go interface, if we go ahead and spell it out, Ethernet 1/5 on these devices. And now if I do where, notice I'm actually connected to both interfaces, both switches under this interface on each of those switches. So I could configure a VPC lickety split. And the cool thing about a VPC in the ACI is that I do not need, I think I may have broke it. So I do not need to configure a peer link or a peer keep alive link because the ACI knows all and sees all. So let me go and take a look at the interfaces of this switch. And let's see if they've actually changed out. And according to this, they are operational. So I'm going to go to configure, and they have not changed. So here's what I'm going to do. Let's exit out of here, exit out of here. I want to go to exit. I want to go to leaf 101. And all I'll do is say interface E1526. And I'll say no FEX associate 101, exit, and let's see if that makes it go away. Yeah, Fabric extenders have always been problematic for me when it goes, and sometimes I find that it's easier to interact with the console than it is with the GUI, especially in situations where your refresh rates are not as great as mine as far as the configs. But if I wanted to add just one other element to here, and that's going to be if I added leaf switch 102 and I wanted to do a port channel, all I'd have to do is highlight these. Since they're on separate switches, the system knows my only option is a VPC. So if I click the VPC configuration here, I've got to type in all of these values. Now, one of the drawbacks to this is the fact that, as an example, let's go to this interface right here. We'll go to interface 2. And what I want to do is I can configure layer 2 functions or layer 2 capabilities. Now on this, I have the capability of saying, hey, what's my speed? Well, I can pick 10 gig. I could come over here and say, how am I going to handle forward airing connection? Well, I inherit from the port. I can hit layer 2 functionality. I can define whether or not I'm going to operate as a trunk. Am I going to operate in Q&Q in version 3.1, which is available? Am I going to define VLANs? Am I going to assign things? Am I connected to a dense wave connection to remote sites? What are the natures of these connections? What VLANs am I going to allow? Am I going to run monitoring, net flow, things along those lines? Am I going to function as a fiber channel over Ethernet port at layer 2? So that means I'm going to have to define how I'm going to function with my priority flow control and my port mode operation. Am I going to be NP or am I going to be a fabric port? These are all things that we have to look at and address. And the problem is doing it this way, we have to do it on an interface by interface basis. And that's problematic. That's really no different than the old school of doing deployments. However, I could choose to use policies to modify these interfaces and their behavior. And the really cool thing about it is I can write a single policy and I can apply said policy to one or more interfaces on one or more switches, again, by leveraging policy. And once everything is good to go, the cool part about that is the policy that I create can be used over and over and over without having to go in and constantly make these modifications. So as an example, if port 3 was connected to a host and that host was in VLAN 10 or VLAN 20 and I had 20 of these guys that were connected, I'd just write one policy and then I would use that policy to be able to implement this behavior. And that's one of the directions that we're going to be going in, and it's probably single-handedly one of the most important directions that we're going to be going in ultimately. But I just want you guys to understand that we can manage this device or this infrastructure, this distributed virtual switch that we've just created, this distributed fabric of nodes that we've created. We can manage it either from the command line, we can manage it from the GUI, and we can do this in the form of what we'd refer to as network centric. So it'd be looking at the ACI in the context of the way that we used to look at the traditional networking. Or what we could do is we could implement this from the perspective of using full-blown policy. This class is going to be focused on policy-based configuration because that's where the rubber hits the road with regard to being able to see the enhancements, the efficiency, and the optimal functionality of an ACI in any network infrastructure. And if you want to connect to the cloud, which is going to be my ultimate goal, is maybe in this class and definitely in an advanced class where we're going to be doing multi-cloud service integration into the ACI. What I want to be able to do is I want to be able to implement that, and that will have to be done in policy-centric configuration because that's where all the payoffs are. So with this being illustrated and said, I'm hoping that this is not intimidating to anyone because honestly, at the end of the day, it is no reason to be intimidated. It's really no different than anything that we've done before. The primary issue or the primary difference between working with an ACI and working with a Nexus is the mechanism and the mode by which we're going to be configuring it. In this instance specifically, we're going to be using the GUI 90% of the time. And I'm hoping, again, that this is going to be, for the most part, 80% hands-on configuration. But we still need to look at some of the other elements because right now what we've just done is we've looked at the physical components. The ACI infrastructure is composed of an APIC, leaves, and the connectors between those leaves and spines. It's also comprised of policies, and we need to understand what policies are, what nature, shape, form, and function those policies take, and we have to understand how we're going to apply those policies to a unique set of logical constructs that is actually going to give us, believe it or not, familiarity when comparing the ACI to the traditional network infrastructure that we've all come to know and love. I'll see you guys in the next video where we're going to be talking about logical constructs, and we're going to do a one-to-one comparison between traditional and ACI infrastructure. Till then, I'm Terry Vinson, and I'd like to thank you for learning data center with me.